Good morning, dear students. Namaste. We are in the seventh part of three-dimensional geometry, and successfully 6 parts are over. Now it is in the seventh part. We discussed about the vector equation of a line which is passing through one point and parallel to a vector b bar. That is, r bar is equal to a bar plus t b bar, where t is some scalar. That is vector equation of a line passing through one point and parallel to one vector. Similarly, the second one is the vector equation of a line passing through 2 points, a bar and b bar. That is, r bar is equal to a bar plus t of b bar minus a bar. Already we discussed and we solved some problems also. And through that vector equation, we derived the Cartesian form also. It is everything is over. Okay, now? Yeah. Now, we are going to find the concept angle between two lines. It is a very good concept. This is a third property. Okay, now? You see, the angle between two lines. Let L1 and L2 be any two lines with DRs. Three-dimensional geometry and vector, both are same. The same concept. It is in the two ways. Okay, now? DRs are in a geometry. And components, the same DRs can be called as components in the vector chapter. Okay, na? Just names are different. You see clearly. L1 and L2 be any two lines. It is purely geometry. Okay, na? Two lines. Horizon, x-axis, y-axis, z-axis. There are two lines. Say OP or OA, O to A. A is a point. O to A. Say it is L1 line. O to B, it is L2 line. Like that. So certainly, the line in the space means no doubt they are having the DRs. DRs, what are the DRs? DRs are the three numbers, set of three numbers which are proportional to DCs. What is DCs? What are the DCs means? They are the cosines of angles made by that OA or OB. Made by that line OL1 and L2. Certainly it makes some angles with the XYZ axis. That they are called as DCs, and from that one we can get DRs. Okay, now everything is known. Okay, you know. L1 and L2 are two lines. Say OA L1 and OB L2. We assume. With the DRs BA1, B1, C1, A2, B2, C2. Okay, now. That is, then we have to show that cos theta, where theta is the angle between those lines. That is understood. Cos theta is A1, A2 plus B1, B2 plus C1, C2 by root of A1 square plus B1 square plus C1 square, the root of A2 square plus B2 square plus C2 square. Now, the proof is, you see, what are given in the statement L1 and L2 be two lines with DRs A1, B1, C1. These are three numbers, three set of numbers. Here also A2, B2, C2. 1, 2, 3, 3, 4, 5, like that. They are the DRs of the two lines. Now we change those two lines into vectors. You see that? Observe. Already, I told you. This is x-axis, y-axis, z-axis, OA, say L1. OA bar is vector. OA simply line is L1 is equal to 0. OB a simply line in the three-dimensional geometry, in the space, OB line. It is L2 is equal to 0. We are naming L1 is equal to 0 means it is a line, OA. O to A, if you change it into direction, O to A, vector, OA bar, OB bar, then those DRs will become as components. You see there. A1i plus A2j plus A3k. Where A1, B1, C1. Sorry, A1i plus B1j plus C1k. A1, B1, C1 are components, scalar components of vector. Those numbers is nothing but drs. L1 line drs. That is simply vector with components like that. The second line A2i plus B2j plus C2k. Now these two vectors, it represents the two given lines. We are given in the statement is lines 1 with drs, and we are making it as vectors. These are the two vectors which represents these two lines. Okay, now that is. Now let theta be the angle between the lines L1 and L2. That implies that theta is the angle between the vector. Line L1 is nothing but y above this vector. This vector is. L2 is no doubt the second vector, this one. Okay, now? Yeah. So theta, if theta is the angle between line L1 and L2, no doubt theta is the angle between those vectors, above vectors. I mentioned here above vectors, means here. These are the vectors. Now, using the dot product, A bar dot B bar, you see, A bar dot B bar is mod A bar mod B bar cos theta. Then what about cos theta? A bar dot B bar by mod A bar mod B bar. Okay, now I am using here this one. Cos theta is A bar is the first vector. Dot of B bar means second vector. By its modulus. Modulus of this one is root of A1 square plus B1 square plus C1 square. Is it that? That is clear. Or otherwise, you write here with the modulus A1i B1j plus C1k. Just like you assume here also, instead of writing this one, it is A2i plus B2j plus C2k. Okay, now this is modulus, just like mod A bar, mod B bar. Then I dot I will there. So A1, A2 plus B1, B2, because J dot J, I dot J, J dot K, they are 90 degrees, cos 90 is 0, it will not be stand. So A1, A2 plus B1, B2 plus C1, C2 is there. Okay, now? And what is the modulus of a vector? It is a positive square root of sum of squares of components. A1 square, B1 square plus C1 square. Similarly, A2 square plus B2 square plus C2 square with root. That is what we require to prove. Okay, Nana? That is the angle between any two lines with drs, means those drs A1, A2 plus B1, B2 plus C1, C2. It is not vectors. By using the vector concept, we are finding the angle between the two lines whose drs are given. Okay, now? That is the thing. Now, here, not if line L1 and L2 having drs A1, B1, C1 and A2, B2, C2, already everything is over. Then the cos theta is A1, A2, B1, B2 plus C1, C2 by root of A1 square, B1 square, C1 square, root of A2 square, B2 square, C2 square. Okay, now you see, then what about sin theta? Yes, okay, cos theta is over. It is a note. That is the property. From that one we are finding the note. Sin theta. Sin theta is root of 1 minus cos square theta. Na? That is from trigonometry. Sin square theta is 1 minus cos square theta. Sin theta is root of 1 minus cos square theta. Formula is there. So 1 minus. What is cos theta? Already we know it. It is a property already solved. Okay, now that is A1 A2 plus B1 B2 plus C1 C2 whole square by this is square means root cancels. Okay, now it is LCM. LCM is A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square minus A1 A2 plus B1 B2 plus C1 C2 whole square by A1 square plus B1 square plus C1 square of A2 square plus B2 square plus C2 square. Okay, da? That implies sin theta is equal. You see that, observe me. After expanding these two brackets and this one, this is A plus B plus C whole square. Three terms are there. A square plus B square plus C square plus 2AB plus 2BC plus 2CA like that. Here also expansion. After simplification, we can get, you see, A1 B2 minus A2 B1 square. Okay, now you see some order is there. A, B, C. 1, 2. Okay, set of A1, B1, C1, A2, B2, C2. Some order is there. A, B, C. Cyclic. 1 to 1. You see, A1, B2 minus A2, B1 square will come. And B1, C2 minus B2, C1 whole square plus C1, A2 minus C2, A1 square. Okay, na? Like this. By it is say A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. It is denominator will not be changed. Same. Under the same root. Okay, Nana? You don't try to solve it. It is not necessary. After simplification, in the exams also, you directly write this one only. By remembering this one. Okay, na? Cos theta already we solved by using the vectors. From that one, it may also asked in the exam. Sin theta. It is an exam. It is an addition to the property. Okay, na? Sub-property. Or simply note. Okay, na? This is the angle between the two lines. Those lines having some drs. For example, suppose L1 and L2 having drs 1, 2, minus 2, minus 1, 1. Then what is cos theta? What is the angle? Cos theta is A1, A2. That is 1 into 2 plus 2 into minus 1 plus minus 1 into 1 by root of 1 plus 4 plus 1. Root of 4 plus 1 plus 1. Okay, now this property. I am using this property. Okay, now it is 2 minus 2 minus 1. This one is 1 into 2, 2. 2 into minus 1, minus 2. Minus 1 into 1, 1. It is root 6 into root 6. Squares are there. 1 square plus 2 square minus 1 square also have 1. 1, 4, 1, 6. Similarly, 1, 1, 4, 6. So it is minus 1 by 6 will come. Okay, na? Minus 1 by 6. It is with modulus. You don't forget, it is modulus. So cos theta is equal to 1 by 6. Okay, na? Mod of minus 1 by 6, 1 by 6. Because why we are putting this cos theta in the modulus means plus and minus are. If we are asked the angle between the two lines acute, you use plus. Or it may also minus 1 by 6. It is obtuse. It is acute. It is obtuseness. If theta, cos theta is positive values, that is in between 0 and 90. So acute angle. Plus, if you take plus, it is acute angle. If you take minus, it is a obtuse angle. Okay, like that. Because suppose this is line, say it is a 60 degrees angle. Automatically it is a 180 minus 60, that is 120. Is it not? It is a line. This side is a 60 degrees. Automatically that one is a 120 degrees. You see, this is L1, this is L2. L1 and L2 having the 60 degrees acute angle. It is also L2, the back side you take. L1 L2, this is angle, it is also angle between the same lines. Okay, now? It is acute and it is obtuse. That is the difference. If you take positive, it is a acute angle. If you take negative, it is a obtuse angle. Is it clear? That is the concept. Yeah. Okay. Now the fourth one. It is also angle between two lines. But there the lines L1 and L2, L1 is equal to 0, L2 is equal to 0. That two lines OA and OB with DRs are given, then that is the third one. Fourth one is, it is a pakka. The lines means with the vector equations. Let the lines be R1 bar is equal to A bar plus lambda B bar. And R2 bar is equal to C bar plus mu D bar. In the vectors, it is clearly is given. Then what about cos theta, the angle between the two lines? Vectors means two lines. B bar dot B bar, D bar by minus of B bar, minus of D bar. How? We will see. Given lines are, proof, given lines are R1 bar is equal to A bar plus it is lambda B bar. And R2 bar is equal, it is a C bar plus it is a mu D bar. Okay, now? Yeah. You see, in the vector equations, it is a line. This line is passing through A. That means A bar point. And it is parallel to the vector B bar. That is the mean. And it is another line having angle theta. It is also passing through the point C. That is the C bar. It is passing through the point C bar. It is passing through the point A bar. That means point A and point C. But it is parallel to the vector D bar. That is the meaning. There is a vector D bar. It is parallel to the given vector D bar. This is second line. Say it is L2. This is first line L1. It is parallel to the vector D. That means B bar and D bar are two vectors having the angle theta. That is the meaning here. You leave out this A point and C point. A bar and C bar you leave out. The line R bar is A bar plus lambda B bar means it is parallel to B bar. Another line C bar plus mu D bar means it is parallel to D bar. So here the lines are parallel to the vectors B bar and D bar. If theta is the angle between the line means the angle between the vectors B bar and D bar is also theta. Okay, now. So here angle between vectors B bar and D bar is theta. Okay, na? B bar and D bar. Okay, na? Therefore, what about cos theta? Already is there. B bar dot D bar by mod B bar mod D bar. It is clear. Okay, na? So the angle between the vector lines which are given in the vector equations is A bar. I mean A bar plus lambda B bar. Okay, then observe. If the lines with vector equations R1 bar is equal to A bar plus lambda B bar, R2 bar is C bar plus mu D bar, where lambda and mu are the constants, scalars. The first line is parallel to B bar, second line is parallel to D bar. Then cos theta is equal to B bar dot D bar by modulus of B bar modulus of D bar. By means already discussed. These lines are parallel to the vectors. One is B bar vector parallel and another one is to the vector D bar, it is parallel. If theta is the angle between the lines means the theta is the angle between the vectors. So cos theta is by using the dot product concept we get this. Yeah. So cos theta is equal to B bar dot D bar by modulus of B bar modulus of D bar. It is the angle between the two lines where the lines are given in the vector equations. R1 bar is equal to A bar plus lambda B bar. R2 bar is C bar plus mu D bar. Okay, Nana? That is it. Yeah? Okay, na?